algebra class, you should have a sheet for vocabulary that looks a lot like this that says substitution at the top that will go into your yellow notebooks whenever we're finished with it. And I want you to think about what the word substitution means in algebra. We've already used this at the beginning where they would ask you to substitute a number for a variable. For instance, x equals 7. And then whenever you saw x in the equation, you would substitute it for 7. X plus 1 equals 10. And then x would equal 9. 9 plus 1 equals 10. Or x divided by 2. Substitute x for 10. Well, 10 divided by 2 would be 5. So they want you to solve for an unknown. Well, this is the same way. We're going to use a method with a system of equations where you'll see what y equals or what x equals. And it literally means, for instance, in a slope-intercept form, you'll see y equals, just as an example, y equals 2x plus 1. So they want you to substitute the equation. If you have another equation that is 3x plus y, they want to know what does it equal. Well, you would substitute this equation for y to determine what x is. So this is a method we're going to use to solve a system of linear equations. So with that being said, the official definition for substitution is, give me just a minute here. Of course, it's not going to let me do it. The official definition okay, it's not letting me launch it. But the official definition for substitution is that you substitute it's a process for solving a system of equations in which one equation is solved for one variable in terms of the other variable. So what does that mean? Well, it means it's something that you do, a process, to solve the equation for one equation where the variable of the other equation tells you what it is. So you can go ahead and pause the video and complete the description for substitution and kind of put it in your own words what your description of it is. Now, my description is that you're substituting x or y from one equation into the other equation that has x or y. And I'm going to give you some, first of all, I'm going to give you some tips for solving, or I am going to give you a couple of tips for solving. So go ahead and pause the video, and then we can talk about some of the tips for solving that you can use substitution for when you have two systems of equations. So one of the tips that I have for you is that when you have two equations, you need to isolate one variable in one of the equations. So you're going to pick one. If you have an equation that says y equals 2x plus 1, you're going to choose that one because it's telling you that y equals something. At the same time, if you have an equation that says x equals y plus 7, you're going to choose a substitution for x because it says x is equal to it. And then you're going to insert that equivalent expression into the other equation wherever you see that variable. So here is a really good example for that. Okay, down below in your very first equation, it has y equals 3x plus 1. Give me just a minute. Let it switch. So wherever you see y in the first equation, you're going to insert 3x plus 1. So your new equation is x plus, in parentheses, 3x plus 1, because that's where y used to be. And they want to know what would make it equal to 5. So then you're just going to solve it. So you have two like terms here. So 1x and 3x is 4x. So 4x plus 1 equals 5. We need to isolate the variable. So you need to subtract 1 from each side. And that's how they got 4x equals 4. Then, of course, they divided it by 4 to get x equals 1. And then after you know what x equals, you're going to substitute that into the original equation that you started with. And you're going to substitute 1 for x so that you can solve for y. So now you know you have an answer for x and y. So look for something that you can easily substitute. So you're going to look for y equals something, or you're going to look for x equals something. And then another tip I have for you is for at least one of the variables, look for the equation that has a coefficient of 1 or a coefficient that is a factor of the other coefficients. And that's your second example. So you want to look for something that has a coefficient of 1. Actually, that's your third example. So in this case, you know that 2x and 1/2 x are a coefficient. There's nothing there that tells you y equals something or x equals something, but you notice that -1/2 and 2 are coefficients of each other. So with that being said, you can rewrite the equation, the second equation, that does not have the fraction in it. You can rewrite it, which is what they've done here. They've rewritten this equation in slope-intercept form so that you have a y equals something. And then they've used substitution for that. And what I mean is they moved the 2x to the other side. And how they did that was they initially subtracted 2x from both sides, but then you're left with a negative y. We don't want that. So all they did was multiplied it by -1 to get y equals 2x, and that's how they got the -5. So I hope you understand that process that we've already studied before. And then with that, they substituted 2x minus 5 where they see the y up here. So they just rewrote the equation, -1/2 x plus 2, and then parentheses 2x minus 5 equals 4. So they've rewritten the equation so that you will get reciprocal or a coefficient of something. Same with your second example. They did that the same way. They rewrote this in slope-intercept form. So they got, or they did not write in slope-intercept form. Right here, it's y equals 4x plus 11. So they use substitution again. Now notice down here, they have a negative x in it. So you have to definitely get rid of the negative because you want your variable to be positive. You always want to solve for a positive variable. So with that being said, you have to multiply both sides by -1 so that you can get it to a positive. My last strategy that I would like for you to use is that you need to use parentheses when you make your substitutions, and that just keeps everything in an orderly fashion. So I've given you 3 tips. I hope that these tips have served you well, and you'll learn more about this in class.